Okay, let's see. So, whoops, that's the formula sheet. Annuities and loan repayments. Okay, so this was in one of your tests recently. I forget exactly when. Anyway, so I'm gonna just go through some questions. Hopefully it will help you. Okay, so we've got a table. Okay, so questions 1 to 4 use the table. Find the value. Oh, just let me point out. So annuity, let's just make sure we know what that means. It means you're constantly putting money in once every year, or it could even be like per month, for example, or something else per quarter. But it means you're regularly putting money in, and it's also accruing interest, gaining interest. But those things sort of interfere with each other. That's why there is a complicated formula, but you guys don't have to do it anymore. It used to be in the general year 12 syllabus, but not anymore. Anyway, all right. So if you're putting $3,000 per year, every year for 6 years at 4% per annum, what? The future value. Okay, how much will you end up with? Let me just do a quick estimate. If you do 3,000 per year for 6 years, that would be $18,000 that you put in. So it's not going to be one of these two. It's too low. This one maybe, but I don't know. 4% per annum. How much is it going to add up to? It's hard to know. So we use 6 years and 4%. This number is our key number. That's sort of the multiplier. So all you have to do, hang on, why is it doing this? You're killing me. Okay, 3,000 times 6.633. This means, yeah, if you have $1, you'll end up with this much. So whatever amount you have, times it by this number to figure out how much you end up with. Alright, so 6.633, 19,899. Okay. Okay, and again, just want to encourage you to, you can write the question down, pause it, take time to read it, figure out your own answer, but I got D. Okay, question 2, okay, it's per month, so we're going to need to convert it. 4 months, 12%, yeah, so don't think, oh, 12% and 4 years, we're going to change it around. If it's, it's 4 months, so 4 is the period, but 12%, if you divide that by 12, it's just 1% per annum, per month, 1% per month, so 1%, 4 periods, this is the number that you multiply by, okay, and it's going to be $800 times 4.06, okay, 4.06, I don't need the 0, but whatever, 3248. This thing, yeah, I don't know why it does that. It's a little bit annoying. I'm just, yeah. It's meant to be 3248, I think. So A. Question 3, find the value. Okay, 9,000 per quarter for 1 year. So if it's per quarter, just times 1 year by 4. There's 4 quarters, so the period is 4. We need to divide 6% by 4. Okay, so just a little tip, whatever the period is, you're going to need to divide the percentage, but you're going to multiply the years, okay? Or if it's months, you don't need to change it. So a quarter of that is 1.5%, divide it by 4, and then 4 periods, so 4.091 is the key thing. Okay, 9,000 times 4.091. Okay, no, I thought that would work. Okay, 36,819. 36,819. Perfect. Hopefully. So C is my answer. What? By the end of each year. Okay, whatever. So it's just the same thing. It's just per year. So 8 years, 3.5. So this is our number. It's really dull. This is why maybe I should have done more examples, but I really feel like it's a simple topic. This one, 9.052 equals whatever. Okay, 21724. I won't write it down, I can't be bothered. And 80 cents. Okay, let's keep going. Now we get another table. Okay, this is, wait, the monthly repayment. This one's telling you what the monthly repayment would be. Okay, on a reducing balance loan, what is the monthly repayment? Okay, so if it's that much money, 8.75%. So this one for 20 years. Okay, there's only one row. Okay, now this is per $1,000. Okay, if it was for $1,000, so if we've got $290,000, we need to times this by 290, and that tells you the monthly repayment. So I'm going to get rid of those. So 290 times 7.57. Okay. Maybe I should set it up so I can always see this. Whatever. 2195 and 30 cents. Okay. Yeah, hang on. Okay, yep, so that one. So that's how much he or she would have to pay per month. Okay, for that long. So just as a follow-up, that's the monthly repayment. Say monthly repayment. So you could say the total paid that they're gonna pay. You could do that. So there's 12 months in a year and it's for 20 years. Let's just do this as a little follow-up. There might be, I'm sure there's probably some questions coming up that are like this anyway. For 20 years, 526, 872, that's it. Okay. So notice they borrowed $290,000, but they end up paying $526,000. Okay. So for example, the interest you could do, I won't write the answer, but you would just do whatever this is minus 290,000. Okay. And then you could even figure out the equivalent simple interest. Actually, why not? Let's just do that. Okay, don't need a calculator for that. Okay, hopefully I'm doing it right. Okay, that's the interest. Okay, why is it doing this? It's always doing this. You want the formula in the center? No, just okay. Okay, then what? Yeah, let's say the equivalent simple interest rate. So just basically saying, all right, it's a complicated rate. It's an annuity, but let's just say, it's a monthly repayment. Let's just say you're paying this much when it only costs that. What's the equivalent simple interest rate? Like this is the amount of interest. Sorry, I don't know what I'm saying. That's what I would do is take the 236,000. If you divide that by the number of years, 20, that tells you the interest per year. Okay, so 236,872, 20, 11843. Okay, so they're paying $11,000 worth of interest each year. Interest per year. I'm just trying to do it as a full-on example so you really get the idea. This is just a hypothetical based on question 5, right? That would be the interest per year, and then the rate would be, sorry, I'll write it like this, rate. You can sort of use a formula, but I like to use logic. We need to compare this to the original, so 843.6 out of 290,000 times 100. Okay, whatever that equals. That tells us as a percentage, and that's the rate per year. Okay, so 4.08%. We'll say 4.084%. Why not? Oh, what are you? Sorry, I thought I clicked there. Okay. Now what was the rate? 8.75. So it turns out because they're paying it off over time, it's equivalent to a simple interest rate of this. Okay. that's just a follow-up for 5. So I hope you know what I was calculating there. It should make sense, hopefully. I'll make that bold. Oh, whoops, it's in German. It's different. It's a shortcut. Alright, Lachlan borrows 245,000 over 20 years. Okay, again it's 20 years, so it's the same. Okay, this is a separate question. I was thinking we have to use the table. Okay, he pays this much per month. It's just asking, all it's asking for is the total paid. So you only have to take this number and times it by, 20 years and 12 per month. So all you need to do is 1856 times there's 12 months in a year and there's 20 years. That's it for that one. So 445440. This one. Okay. Notice I didn't use the 6.5%. Okay. You just have to pluck out the important parts to figure out the answer. Okay, Alicia borrows 40,000 over 5 years. Okay, total pay, easy. That much per month for 5 years. We don't even need to know the other parts. Okay, so that's for this one. So 765, there's 12 months in a year, and it's 5 years, or 12 times 5 is 60. You can also do that. I'll do that, 765 times 60, do the same answer. 45,900. So B is the answer. Okay? Alright. Okay, so we've got a table. I don't think I'll do all of them. I'll pick and choose. I think I don't want to do that many. You should get the idea. You're welcome to pause it and do more. So the first one, okay, so this is the future value again. So you just sort of multiply for 18 years, 10%. So it's yearly, so 10%, 18 years. So this number, so you just do 6,000 times 45.6. Okay, so 273,600. Okay, so that's how much it will be worth if you invest $6,000 every year for 18 years, and you're also getting 10% per annum every year. As it increases, you'll end up with this much at the end. Okay, let's skip down to one that's not per year. Let's do this one per. Oh, I'll do one more that's per year. 940. Okay, I'll try to label this. I want to be organized. Okay, I'm gonna do C. So I would just do 940 times now 12 years, 6%, 16.87. Easy peasy. Whoops, I opened the wrong thing. Go away. 0.87. Okay, 15857. This is exciting, isn't it? It's amazing. Alright, let's skip to a harder one. Let's try G. Here we go. 2,800. Okay, per quarter. I'm still going to times it by something. So instead of 6 years, how many quarters is that? So just times 6 by 4. 24 periods. So 24 and 8%. So we need to divide that by 4 as well. So 2% per quarter. So 2%, 24. 30.42. Okay, and 2 times 30.42. Okay, 85176. And again, I encourage you to check your answers that they seem reasonable. I always try to do that. So if you're putting 3,000 in 4 times a year for 6 years, 8%, okay, maybe you get 85,000. Alright, let's just do one of these ones per month. Do J. If it's per half year, you just double the 12 to 24 and halve that one. But let's do J. So it's per month. So if it's 12 months, okay, it's just 12. And 48% per annum, divide that by 12. That is huge. That's crazy. But it'd be 4% per month. So 4% for 12 months, 15.03. Okay, 420 times 15.03, 631, 6312.60 cents. Okay, so I hope that makes sense. Unintentional pun. Alright, this one. Yeah, the table in question 1, same table. Oh, okay, working backwards, I think. Oh, okay, yeah. I think it's just almost the same thing. So, okay, fine. Question 2A, whatever. So we're aiming for $60,300. How much do I need to put in per year for 6 years if it's that? So we still use the same thing, 6 years and 4%, so 6.63. But I'm just going to start with the number 6,300 and divide by 6.63. Okay, let's see what number we get. Okay, so 9,000. Okay, and 2 cents. So if you were putting in 9,000 per year for 6 years or whatever it is, 4%, okay, you would then have to times it by that to get the future value. So we're just dividing. We're working backwards, okay? These are all the same. Look, I don't think it's worth... I'll do one more. Let's do a biannual one. Let's do F. Hopefully you get the idea. So we're still going to divide 500 divided by, okay, so it's compounded biannually, that means twice a year. So instead of 12%, make it 6%, and instead of 12 years, make it 24 periods. Double that and halve that. So 6%, 24, 50.82. So I need to divide by 50.82. Okay. Okay, 383.71 cents. Okay, so wait a second. Which one is that? Yeah, okay. If you're doing it for 12 years, twice a year, getting quite a bit of interest, yeah, you only need to put $383 in each time, and you'll end up with 20,000. That's reasonable. Gee, 1,200 at the end of each year for 6 years. I don't see how this is exactly the same thing. 12, just do it with 1,200. Okay, 6 years at 8%. So like 6 years, 8%, 7.34. So just do that times 7.34. Let's move on, something different hopefully. Okay, present value is actually kind of confusing, but it's like, you know, okay, if after, let's say 20 years you end up with that much, that's not as good as if I had that much money now. Having that much 20 years from now might be equivalent to having $190,000 now, or something like that. It sort of changes. So that's what this is telling you. So it's sort of how much money is it worth now? Equivalent. So, alright, let's just do a couple. Whatever. Question A, so 25. I still think we're going to times. For 36 years, it's annual, so 36, 3%. This is the number, so times it by 21.83. Why did I put a comma? Not for typing. 545. 750. So just to make sure it really sits with you, if you invest 25,000 every year for 36 years with this interest, so you don't actually end up with that much money, but you end up with a certain amount of money that it's the same as if you invested this much money right now. I think at the same rate, just assuming the same rate. If you invested this much money right now, that would be the same as doing that. It's sort of equivalent. Alright, let's just do one more. They're all annual, quarterly. Alright, I'm going to do G. because they really are exactly the same. 9,500. So it's per quarter, so times that by 4 is 48, and divide that by 4 is 2. So 30.67. I think just to emphasize, alright, let me write this first. 291,365. Okay. Yeah, just to emphasize, I think the hardest part of this topic is not these calculations, but knowing when to times, when to divide, when to use a number from the table, or when to just use common sense. Like if it's saying, I forget where I said it, but the total amount paid, I think it's the previous page. The total paid, you just times the monthly payment or whatever by how many months. That's it. Just remember, annuities, you don't use any formulas, not really. Okay, it's all just step by step, use a table, multiply. Alright, I'm going to go down to this. Okay, okay, so this is, it's saying find the contribution if you have the present value. So this is a dividing one. So I'm just going to do one. Let's do this one, E, 5E, okay? Okay, so I'm going to start 87,000. I'm going to divide it by 12%. So it's quarterly. So divide that by 4 is 3%. And it's going to be 24 periods. So I think I lost 3%, 24. So this one, 16.94. And I'm dividing because I'm not finding the present. Sorry, yeah, I know the present value, I'm finding the contribution, the annuity, how much you're putting in each period. So working backwards. Alright. Gee, alright. That's a fair bit. 5135. Okay, and 77 cents. Does that make sense? I guess 87,000 is a fair bit. And that was, yeah, okay, so only 6 years. Only 4 times a year, so I guess you got to put in 5,000 every time if you're going to end up with 87,000 after only 6 years. Alright, last one. Okay, the total amount, easy. I don't even need to know the interest rate. I just need to know that monthly payment. So it's total repaid. Oh boy, what's it doing? So 1580.75, and then times that by 12 months a year, and it's for 20 years, whatever that equals. Okay, so 1580, 379, 380, $379,380. That's the total amount. How much extra is for 30 years? Okay, so maybe you want to write that, something like that. 20 years. Okay. Same exact thing. 30 years, 1364.35. So still 12 months in a year, but this time it's 30. So it's sort of a compromise. Instead of, it's a lower amount per month, but it's for a longer period. Okay, and it should end up with a higher total because that interest is lasting for a longer time. It's sort of like what am I doing? I'm getting mixed up. If you're in debt, you want to pay it off as quickly as possible. But if you're earning money, you want that interest to last. The longer the better. So 491 166. Okay, 491,000. So then you just subtract this one, take away that one. Okay, and that'll be the oops. So how much extra, and I can't be bothered, 491 blah 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 minus 379 blah blah blah. Okay, 379. Okay, sorry, whatever. I can't be bothered. It's just that difference. So I hope that helps. That's it. Yeah, I feel like this is a simple topic. You just need to read carefully the key numbers. So this says calculate the present value. Okay, meaning you just need to take, this is the annuity, so just, and it's per year or per whatever. Just times it. If you're finding the contribution and you're given the annuity, you're given the present value, this is the present value, then you need to divide in the table. Okay, and just don't forget to convert if it's quarter, biannual, monthly. Okay, alright, hope you learned something. Bye.